This is lesson 80 on pages 162 and 163. Okay, trigonometric ratios. The idea of taking, in this case, a ratio is just comparing two numbers, writing it in its lowest term, looks like a fraction, and we're going to look at them in a right triangle, and we will use somewhat the concept of the Pythagorean theorem. So I'm just going to draw just a generic right triangle. Now, a lot of times with a right triangle, and you ask somebody what the Pythagorean theorem is, they'll say a squared plus b squared equals c squared, and I usually say, well, what are a, b, and c? Well, when you do it that way, you're letting little a be one of the legs, little b be one of the other legs, and then the c is the hypotenuse. So it is true, we know leg squared plus leg squared equals hypotenuse squared, which is what you have to know. And then if you say that you know the legs are a and b, we can say a squared plus b squared equals c squared. Well, also in that triangle, we don't talk much about the angles. We have used them, but we didn't usually letter them. But when you take side A, the little letter A, and go across from it, the angle across from it is the point A. That's the vertex across from it, and we'll talk about that as angle A. And then if you have B here, and then go across to it, to the angle that's across from it, then that's angle B. And then across from the hypotenuse is angle C. Usually C is your right angle, and usually the little letter C is the hypotenuse. Well, mathematicians many years ago saw that there was relationships between these numbers, no matter the size of the triangles. They ended up having some of the same relationships, even if you had a little triangle and a big triangle, but if they were similar, and we know that similar triangles are the same shape, the angles are the same, but their sides are different, but they're going to have the same ratios or comparisons. So they actually defined 6 trig ratios. We're going to only talk about 3 of them. We usually just deal with 3 in Geometry Algebra 2, and that's usually all the ACT deals with. And the first one is called sine of an angle. And I'm just going to put the sine of, I'll just put sine of an angle. Probably the easiest way to say it. And then we say the abbreviation for that is SIN. Now, that's not pronounced sin. If you say sin, somebody says, oh, they don't know their trig very much. But it's sine is how you pronounce it, but that's the abbreviation for it. So the sine of an angle is equal to, and usually there's going to be a letter there, A, B, C, whatever triangle you're talking about. And the sine is going to be the ratio or the comparison of the opposite leg from that angle over the hypotenuse. I'm just going to abbreviate that if that's okay with you. So if I look at my picture, well, I tell you what, before we do that, let's just stop at that point and we'll just define them, then we'll come back. So then we'll say the second one is cosine of an angle is equal to, and the abbreviation is COS, not cos, but cosine, you say the word, even though it's an abbreviation, is equal to the adjacent leg over the hypotenuse. And then the tangent of an angle is abbreviated tan, but it's pronounced tangent. You don't want to say tan, you want to say tangent, is equal to the opposite leg over the adjacent leg. Now, there's a short little saying that makes that easier to learn, and I'll give that to you in just a few minutes. But let me show you where we're coming from in that. So let's go back up to this picture here, and I think if we keep it on I think we can keep it on. If not, I'll redraw it down here. Let's look at our angles. Now, in right triangle trigonometry, we're not going to talk about angle C. We only talk about the acute angles. So we can talk about the sine of, and I didn't notice, I think your lessons don't put angle A. I think they just put sine of A. They just put A, and that means go to angle A. Now, look at what we're looking for. We're looking for the opposite leg. Remember your two legs, A and B are your legs, and C is your hypotenuse. And you're looking for the opposite leg from this angle A. So when you look at it, and I go across from angle A, notice that side A is across from angle A. And then it wants the hypotenuse, and the hypotenuse is C. And so that's the generic ratio of the sine of angle A. Well, what about the sine of angle B? Well, the sine of angle B would be, here's B, and again we're looking for sine, the opposite leg. So the leg, these are the two legs. And what we mean by adjacent here, because we're going to talk about the adjacent one, notice that B and side B, it's across from it, opposite it. And then angle A, side A is attached to it. It's adjacent to it. So this would be the adjacent leg, and this would be the opposite leg. So we want the opposite leg, which is B, over the hypotenuse, which is C. Well, let's do a third one, just to kind of get comfortable. Then we'll throw into it what you're going to see in classwork. And I do need to give you the shortcut. Let's do the tangent of angle A. Again, we don't use the right angle in triangle trigonometry. You do that in circular trigonometry, which is usually your more advanced topics, college algebra, that level. So the tangent of A is the opposite leg over the adjacent leg. So it's going to be these two legs. Now, how are they compared? From angle A, side A is the leg that's across from it, opposite leg. And then the adjacent leg is the one that's actually attached to it. So you've got angle A here, and the leg, a lot of people want to say C, but remember, C is the hypotenuse. So we only use that in sine and cosine, and you want the opposite leg and the adjacent leg. And that's going to be B. Now, we'll put some numbers in it. Maybe it'll make a little more sense to you, but the first thing I want to do is give you the shortcut. And you need to write it on your paper, help you remember it. There's different ways, people pronounce it different ways, but it's SOH, CAH, and TOA. Now, I've always said SAW, and when I do that, it almost sounds like SAH. So I need to do a better job of pronouncing that, because it really should be pronounced SOHCAHTOA. Silly joke about Indian chief SOHCAHTOA and the story about the trigonometry, but that's the way that people remember it. And I tell Algebra 2 students to write it at the top of the paper when you get started taking it. So, and I'll do a better job of saying SOHCAHTOA. And what's that going to help you? Well, look at sine. Sine is opposite leg over hypotenuse. So SOH. So SOH. Sine is opposite leg over hypotenuse, or just opposite. That's just a little shortcut for you. Cosine is the adjacent leg over hypotenuse. And then tangent is the opposite leg over the adjacent leg. Okay, let's try one. I've got a triangle here, and it's turned this way. I don't know if a ruler really helps, but at least it does look like a right triangle. Sure do miss my geometer. And we're going to let this triangle is triangle X, Y, Z. Now look where your right angle is. That's angle Y. You've got X and Z, and those are two we're going to talk about. And they give you the measurements of XY is 12. And 16 is YZ. And 20 is the hypotenuse. Now, if you do the Pythagorean theorem, 20 squared equals 16 squared plus 12 squared. See, that is an example of the Pythagorean theorem, very much involved in trigonometry. Now, in your classwork, you'll only be asked to do one problem per picture, but we're going to go ahead and do several so we don't have to draw a lot of pictures. So the first one I'm going to do is, let's do the sine of X. Let's do the cosine of Z. and let's do the tangent of Z. So that'll give you a feel for one picture, 3 different problems. So I've got my SOHCAHTOA right in front of me. So I'm looking at sine, and I know I need opposite over hypotenuse. So let me first find angle X. It's right here. So I'm looking. Let me kind of wrap my head around what I got. Well, 20 is the hypotenuse. These are the 2 legs. 12 is the leg that's adjacent to X. And 16 is the leg that's across from X. So we need the opposite. I can even write SOH right here. So sine is the opposite leg over the hypotenuse. Now, this one needs to be reduced. I didn't leave enough room for it. So I'm going to divide by 4 over 4. 4 goes into 16, 4. 4 goes into 25, and I get 4/5. Okay. Let's do the cosine of Z. Well, first find angle Z. Kind of wrap your head around it. There's the hypotenuse. There's the opposite leg, and there's the adjacent leg. So if I want this angle, cosine Z, then I'm going to do the adjacent leg, the adjacent that's attached to it, which is the 16, over the hypotenuse, which is 20. Divide by 4 over 4, and again, we get 4/5. Now, it's kind of interesting, but you're really only dealing with 3 numbers, and when you put these as fractions and start reducing them, you're going to see some similarity in them. And then the tangent of Z, here's angle Z down here again, and we need the TOA, T-O-A. So we need the opposite, we need the 2 legs, we need the one that's opposite it, and we need the one that's adjacent to it. So we need 12 over 16, and you want to be sure and reduce them. And this one again divides by 4 over 4. 4 goes 3 times, and 4 goes 4 times. So I get 3/4. Okay, I'm on page 163 now, number 2. I'm going to turn my picture a little bit different, just to, not confuse you, but just kind of throw things in different directions, because you're going to see them sitting different in the, let's see, how do I want to do this one? Let's put the right angle over here. Okay, and this one is going to be, let's do, and you have to be careful, because I noticed in the classwork that some of them don't put angle C at the right angle. So let's go ahead and do one like that. So let's do ABC, so that you don't look at it and always assume that side C is going to be the hypotenuse. So if you've got, here's your 2 legs, AB and BC are, and then the hypotenuse is AC. And the hypotenuse is 41. The short leg is 9, and the long leg is 40. Okay, you can check it with Pythagorean theorem. 40 squared plus 9 squared equals 41 squared, and that is a right triangle. So let's do the sine of C, the cosine of A, and the tangent of A. So sine of C. Well, let's find C first, kind of get our bearings. Leg adjacent, leg opposite, and hypotenuse. Well, SOHCAHTOA. So I need the sine. So with angle C, I'm looking for the leg that's across from it, opposite. That's 40. And the hypotenuse is 41. Now we like this one. That's already reduced. It won't reduce. Now we need the cosine of angle A. So this time we need the angle A up here. So we need the 2 legs. That's the opposite. That's the adjacent. See, what's opposite of this one is adjacent to this one. So you have to be careful. Angle A's adjacent will be the 40, and the hypotenuse will be the 41. Now, if I had asked for the cosine of C, because I keep doing the 2 that are the same, but if I'd done cosine of C, then the adjacent was the cosine is adjacent, is 9, adjacent leg, over the hypotenuse, which is 41. So really just getting in your mind where the legs are and the hypotenuse is. And then the tangent of A is going to be the opposite leg of A, which is 9, and the adjacent leg of A, which is 40. It's not going to involve the hypotenuse.